Hello, everyone. Good morning. Okay, so for today, we'll be discussing on the next lecture, lecture 4, chapter 4. So this chapter it's divided into two parts. So we have part 1 and part 2. So today we will cover on part 1 and next week continue on part 2. Can we start? Mm, thank you. All right, so this is Chapter 4, Part 1, Relational Model. Okay, relational model. So we go to the next part of this course. We will be discussing on relational model related to relational algebra. Okay, so let's look at the learning outcomes for this chapter. Okay, so we will be discussing on how to formulate queries in relational algebra. Okay, and then you should understand the basic concepts of query processing and optimization according to the relational algebra. Okay, so um, you should uh, you should be able to do this after we have finished discussing this chapter this week and next week. Right, so some introduction. So this relational algebra, it's a procedural query language that works on relational model. Okay, so this relational algebra, it's used to as a guideline to be used on relational model. Okay, so we have discussed on relational model previously. So today we look at relational algebra. So the purpose of a query language, in this case is SQL. In our course is SQL. So we want to retrieve data from database. Okay, so this SQL is a practical implementation of this relational algebra. So it's also known as RDBMS, Relational Database Management System. So it's a practical implementation of relational model. So basically, it's the theory or the concept of um, of database for us to use in relational model. So today we look at relational algebra that I use on relational model. Okay, so some introduction on relational algebra. So the relational algebra, it consists of a set of operations that take one or two relations as an input and produce a new relation as the result. So relational algebra, will you will do a relational algebra, um, it, in which we will be taking a set of operation to create a relation and produce a result as a new relation. Okay, so we look at some example after this. So these are the five basic operations that we have in relational algebra. So we have selection, projection, Cartesian product, union, and set difference. Okay, so we look at some of these today. So this basic operation perform most of the data retrieval operation needed. So other than these five basic operation, we also have derived operations from these basic operations we have here. We have join, we have intersection and division. Okay, so we will also look at this derived operation in this chapter. Okay, so let's go to a case study. So we will be discussing the chapter today according to this Dream Home database. Okay, so this is a case study. You can find this in our ebook as well. Uh, you can find it at the ebook the Pearson one. So you can find the detailed discussion on case study regarding this Dream Home database. Okay, so we have six tables. Okay, we have six tables. We have branch, we have staff, property for rent, private owner, client, and viewing. So this Dream Home company, it's a property management company. Okay, property management company. Okay, you can see property for rent, and who is the private owner of the property, who's the client, and the viewing, and the attributes that we have inside this table. So each branch, okay, so each branch, it offers a range of properties to of rent. So we have several branch, and we have several type of property to be rent under this company. Okay, so throughout this lecture, we will be using this Dream Home company database for our example. So here is the Dream Home sample relations. So we have the branch table, we have the branch number, the street, the city, and the postcode, and staff table. As you can see here, we have a foreign key here, foreign key, and then the staff attributes. We have the staff number, first name, last name, position, the sex, and also the date of birth, as well as the salary. Okay, so we'll be using the data that we have here for us to understand the relational algebra after this. And then the next one, we have property for rent. We also have the foreign key here, staff number, branch number, and then client, and then viewing. Okay, so the relational algebra that we will look at after this will refer to these tables. Yeah. The next, these are the representation of relational algebra operations. So we have selection, looks like this. We will look at this in detail after this. Okay. So this is just to show you how the operations look like. So we have a selection, means we select some data from the table, and we have projection, look like this, and we have Cartesian product. This one also it's represented as this, and then union intersection, and set difference. Okay, so they this one I think we will not cover this one, but it's not included in this lecture. But you can have your own read for this Cartesian product from the ebook. Yeah. Okay. So this one natural join. We have natural join, semi join, represented by this character here, left outer join. So this one we will discuss start, today we discuss up until natural join. Next week then we discuss the next part. Okay, so we have semi join, left outer join, division, and example another example of division. Okay, so don't worry if you don't understand this for now. We will look at the database and try to relate to the relational model that we have studied last week. Okay, so for relational algebra, it has symbols for each of the operation that it has. So the first one is projection. So the representation is this one is pi. This one is pi, right? Pi. And then for selection, it's this one, this symbol, sigma. And then rename this one is rho, RHO, rho. Then natural join represented by this symbol, left outer join, this symbol, right outer join, semi-join, division, union, intersection, and difference. Okay, so you need to be familiar with all of these symbols. So we go to the first one. We have the first relational algebra that we will look at. The first one is selection, or also known as restriction. Okay, so the symbol here represent the operation selection or restriction in relational algebra. So this sigma, and will have a predicate. Okay, a predicate. So and also the statement here, the table. Okay, the rows. So this selection operation, it works on a single relation R, and it defines a relation that contains only those rows, or known as tuples of R. Okay, R here is the table, referring to the table. So it will only look at the relation, it will only define a relation that contains only rows that satisfy the specified condition. Okay, so we will see condition state here and the predicate. So the predicate is the specified condition. So it will display all attributes of the relation. So the result of this operation, you will get all the attributes of the operation of the relation. Okay, so I repeat, for this selection operation in the relational algebra, we have the the operation as sigma predicate R. Okay, so predicate is referring to a specified condition that we want to find, and then R is related. R is the table. Okay, so this operation will only define a relation that contains the rows or the tuples of this table that satisfy the predicate that is stated here. Okay, so the result will be all attributes of the relation that satisfy the specified condition. So let's look at an example here. So here we want to list all staff with a salary greater than 10,000 pound per euro. Pound. Yes, so 10,000. So so here the table is staff. Okay, table is staff. The table is staff. So R is staff, and then the condition or the predicate. The condition or the predicate in in this operation is that you want to get a staff that has a salary more than 10,000. Okay, so this operation only will satisfy this condition according to this table, right? So sigma, the predicate, you want to find the salary, you want to find a staff that has a salary more than 10,000. Okay, so now we have this staff table here, so you can see this all the staff, so we can see the salary from here. So this operation will refer to the salary row and check the condition that is specified here. So the selection will create a new table containing only those staff row, okay, with a salary that's greater than 10,000. So the result is given here. Okay. So when this operation is run, this operation will look at the salary tuples, the salary row, and it will it will only provide you with a result with only those staff rows that has a salary greater than 10,000. Okay, so the result of this operation is shown here. Yeah, so we have four staff with a salary greater than 10,000. Okay, so I repeat, for this selection, we have a predicate, which is a specified condition, and then it will refer to a single relation. Okay, so here is the table where it will refer, and it will only define a relation that contains the specified condition in this operation, right? So we have the condition here and the R here, the table. So we refer to the salary row, and it will satisfy the condition here, salary greater than 10,000, and will give you this result. Okay, so fast. Okay, can follow.
Okay.
Okay, thank you. All right, so this is for selection, or also known as restriction in relational algebra. Okay, so next we look at another one, projection. Okay, so projection, this is the symbol. So this one also works on a single relation, R. So single relation here is referring to a single table, and it will defines a relation that contains a vertical subset. Okay, vertical subsets of R, so the vertical subset of the table that's specified here, which only extract the values of R with a specified attributes, and it will eliminate duplicates. Okay, it will eliminate duplicates. So this operation project yields value for selected attributes. Okay, so here this is the statement, or this is the operation of projection. You will have um, a vertical subset of R, which only it will extract the value of specified attributes here. Okay, and at the same time it will eliminate duplicates if any. Okay, so let's look at example of this projection. So here we're still referring to the dream home database. So this is an example of projection operation in relational algebra. So we want to produce a list of salaries for all staff, a list of salaries for all staff, showing only the staff number, the first name, the last name, and also the salary details. Okay, so in this example, the projection operation, it defines a relation that contains only the designated staff, which refers to the attributes of staff number, the first name, the last name, and also the salary in a specified order. Okay, in this specified order. So the result of this operation will give you this result, right? So it gives you the result of the staff number, okay, according to the order, the first name, the last name, and also the salary. Okay, so this is a projection. So this one also, for projection, it also refers to a single relation, means only one table. There's no other relation, no other table that refers to. Okay, so this one is, I think it's very straightforward. It will produce you a result according to the attributes that is required by this projection, this operation. So it differ with the with this selection or restriction. For selection, it specify a condition. Okay, but for projection, it specify attributes. Okay, specify the attributes that you have under this R, under this relation, which refers to the table. Okay, so now question. So given the following SQL statements, write the related relational algebra. Okay, so the one that we discussed just now. So which we use this SQL statement to get the same result that we have that we discussed just now. So this one, what's the answer? Can you type in the chat? What's the related relational algebra for this? So look at the statement. So your midterm test can ask this kind of question. You can ask this kind of question like you need to specify or you need to write the relational algebra for the SQL statement. Okay, so this is your homework. So you can try. I think we'll finish early today. So I want you to go back to this slide and try to look at what is the relational algebra operation for this. Okay, so you select staff name, first name, last name, salary from staff. Okay, so this one should be the R, and then you have a condition. Okay, so this one is very simple. You try later. You try to write the relational algebra. Okay. So before we proceed to the next one, I give you 5 minutes break. And so 5 minutes break if you want to try to do this. Yeah, you can copy paste juga. Projection atau yang depan tu Ian. Projection. So you have staff number. And then That's selection, right? Sigma. Yes. Yeah. Yeah, something like this, something like that. Okay, so we will actually have another operation in between. Means you need to like combine the operation of operation of projection and also the sigma, the selection. We will look at it after this. So thank you, Ian, for your input. So we take five before we proceed to the next part. Can you do that? Yes. So union, we use union kan? Okay, can we continue? Is everybody here? Okay, thank you. Okay, so um, Russell has given the answer. So projection, sorry, selection kan? Selection, stock number, oh no, projection, stock number, you show the attributes of stock number, the first name, the last name, the salary, referring to the staff table, and then you union it with a sigma, the selection of salary less than 1,000, referring to staff table, right? So thank you, Russell, for your answer. So actually, we will look at the next project, the next intersection. Jordan, why oh yeah, union is like this. Sorry, I messed up the what the symbol. Okay, so this one is union, and later we look at intersection. I think we have intersection later on. Okay, so thank you, Russell. Section. I'm not sure if we, yeah, we have later. Okay, so intersection, this one. So you define a relation consists of the set of all tuples both in R and S. So it satisfy both condition your in your projection and also your selection. Okay, so the enzyme right is the intersection. Okay, so later we'll discuss on that. Thank you, Russell. Okay, so next, can we continue to the next part? So we go to the next operation. So the next operation that we'll be discussing is union. Okay, union. So the operation is this, U. Okay. So union is of two relations of RNAs, okay, RNAs, which defines a relation that contains all the row of R or S or both R and S. So duplicate will be eliminated. Okay, so RNS it must be union compatible, means you need to have a same attribute. So this union it's only possible if the schemas of the two relations match. That is, if they have the same number of attributes with each pair of the corresponding attributes that having the same domain. Okay, so it must have, in other words, this the relation it must be union compatible. They're referring to same attributes. So they need to have the same number of attributes with each pair of the attributes having the same domain. So not that the attribute names it's not used in defining the union compatibility. So the union of the two relations R and S defines a relations that contains only all the row of R or both R and S, and it will eliminate any duplicates. Okay, so this is how it looks like in diagram figure. So we go to the next one to see an example of this. So the example of when this union operation will be used. So the company A has bought another company B. So this is a scenario, yeah. So let's assume that a company A bought another company B. So these two company has two customer tables that require merging. So you want to merge company A and company B. Um, you want to merge the customer tables. Okay, so merge the customer table with customer two table using union. So you will be able to merge the tables using this union operation. Okay, so this is a scenario where union will be used. So there, here, the duplicates will be eliminated, okay, from company A and company B. So let's look at example of union operation according to the Dream Home database. So to produce union compatible relations, we will first use a projection operation to project the branch and uh, project the branch and property foreign relation over attribute city. Okay, we look at the attribute city. So here we want to list all cities where there is either a branch office or a property for rent. So we want to list all the cities. So we refer to city where there is either a branch office or branch office or property for rent. Okay, so this will we use union so that it will eliminate duplicates where necessary. So we use union operation to combine these two new relation. Okay, new relation using union projection, a union operation, and it will produce this result. Okay, so when you run this operation, you will get this result. So if you see here, there's no no duplicates. It has been eliminated. If you see here from the property from rent, we have duplicates, and this union operation has eliminated the duplicate, and it gives you the result of where the cities that there is either a branch office or a property for rent. So in this city, we know that there's either a branch office or a property for rent available for rent. So union based on the city attribute uh, shown in this result. So it is from the branch and property for rent relations. Okay, sorry for the delay. We just left. All right, so we continue, yeah? So we have looked at union. So here I repeat for this example. So we want to produce a result where it lists all the cities where there is either a branch office or for property for rent. So we use projection to get the city. We look at the city and we refer to branch table and we get the city from property for rent. So we'll get this result. So the union based on this the city attribute. So the union here is based on the city attributes from branch and property for rent is listed here. Okay, so we have London, Aberdeen, Glasgow, and Bristol. Right. So in SQL, okay, in SQL we can write it. We can write the query like this. Okay. So we want to list all cities where there is either a branch office or property. So we'll select city. So means we select the attribute city from branch. Okay, from the table from table branch where city is not null. So means there must be a value of city. And then we use the operation of union. Okay, union. And then you select city attribute from property for rent where city is not null. Okay, so you pick you only select city for from these two table, branch and property for rent, and you use union operation. Okay, to get the cities where there is either a branch office or a property. Okay, so in relational algebra, this is how the operation look like. In SQL, in the relational model, this is how we write the SQL query. Okay, so this one is very simple. So maybe in your if this kind of question can ask in your midterm test or in exam, it's not this simple lah. Okay, so maybe it's a little bit advanced, maybe more more table for you to do the operation. So you need to understand the basic concept of the relational algebra operation. Okay, so we have looked at selection or restriction, and then projection, and we have looked at union. And now we look at set difference. Okay, set difference. So this set difference operation in relational algebra, it this operation it defines a relation consisting of the tuples that are in relation R but not in S. Okay, so it's the tuples we define the tuples that are in relation R but not in S. So you R minus the minus operation with S. So R and S it must be union compatible. Okay, it must be union compatible. So let's look at the example for set difference. So we want to set difference for we want to list all cities where there is a branch office but no properties for rent. Okay, so previously we use we want to list the cities where there is a branch office or properties for rent, so that we use union. But this one we want to list cities where there is a branch office but no properties for rent. Okay, so here we still use we um, we produce the union compatible relations by projecting the branch and property foreign relation over the attribute city. Okay, so as in the previous example, we produce we produce the union compatible relation by projecting the branch and property foreign. Okay, in the previous in the previous example for union. So now we want to, because we have this condition, no properties for rent, but we still refer to this branch and property for rent. We use set difference operation, this operation to combine these two relation, okay, combine these two relation, these two projection to produce the result here. Okay, to produce the result of this query. Okay, so we want to list all cities where there is a branch office but no properties for rent. So we want to have the result uh, where it lists the city that has a branch office but no properties for rent. So we use set difference. Okay, so different with the previous one. We want we list the cities where there is either branch office or property for rent. Okay, so um, we list all cities that has either branch office or property for rent. Okay, for this example here, we set difference. We want to list the cities that there is a branch office but no properties for rent. Okay, so we get this result. So in SQL, in SQL, so we want to list off of all cities where there is a branch office but no properties for rent. So we use this operation, okay, except. So we select all city, we select city from branch, except select city from property for rent because we don't want to list cities that has no property for rent. Okay, so we get this result, right? Any questions so far? So far, so good.
Okay.
Okay. So this is for set difference. So in SQL, we use this operation. Okay. So next is intersection, the one that Russell include in his answer just now. So this intersection is the opposite of union. Okay. So the intersection operation, it defines a relation consisting of the set of all tuples that are in both R and S. Okay, both R and S. So it must be union compatible. It must be union compatible. So this intersection, you define a relation that consists of the set of all tuples that are in both R and S. So how about union? Open that, go back to union. So in union, we define a relation that contain all of tuple R or S or both R and S. So it can be or, it can be and. For intersection, we want to define a relation that consists the set of all tuples or all row that consists in both R and S. Okay, so when will we want to use this operation? Okay, so intersect. So let's say, for example, in this scenario, so the management, they wants to know which customer are dealing with both companies. Okay, so customer which deal with both companies are considered not loyal. So we can use this uh, intersect intersection operation. We combine rows from two queries. Okay, combine rows from two queries and returning only the rows that appear in both sets. So we combine rows from two companies of a customer, and we will get a result of the rows that appear in both sets. So means you will get a result which show you on the customer name that is dealing with two companies. Okay, so you have two company, company A, company B. So you want to see which customer that is not loyal, for example. Okay, so you want to know which customer is not loyal. So you get both um, you get two queries. You do two queries and you intersect them, and it will show you the row or the customer that appear in both company. Okay, so that will give you the information that this customer from this intersect operation is not loyal. Okay, so this is just an example of a scenario. So now let's look at example of intersection according to Dream Home database. So here we want to list all cities where there is both a branch office and at least one property for rent. So as in the previous example, we produce union compatible relation by projecting the branch and property rent relation over the attribute city. So here it's similar, but here we use intersection operation, okay, to combine these two new relation. We combine this relation to produce this result. Okay, so this the intersection projection, the intersection operation result. So you get Aberdeen, London, and Glasgow. Okay, so we use a projection referring to the branch table according to the city attributes. City attributes from both branch table and property for rent. So we do the intersection. So this we get this. Okay. So in SQL, so this is the query that we use. Okay, intersect. So list all cities where there is both a branch office and a property. So we select city from branch and intersect with city from property for rent, right? So why did you use intersect rather than union just now, Russell? Can you share why intersection? The intersection and in programming and and you mean intersection is like and yeah, I read the symbol. Okay, so is it intersection or union? And yeah, it's n this one n, right? So from this query, from this query that we want to do is also it also state here n, right? Because of that, right, Russell? Is that what you mean? This one, this n, the concept. Okay, thank you. Let's go back to union. We just want to check that. And then, okay, so here we have or for union it's or, right? So for n means you satisfy both statement. You satisfy for n, you satisfy both query. Thank you for sharing yourself. And so and from here for DC we want to list cities where there is both a branch office and Okay, so union it's or, it's either have or don't have. Okay, so this is how we use it in SQL. Okay, so now we look at join operation. Mm, so today we look at natural join. So a join operation we have various form of join operation. So this the some overview of a little bit of overview of what is this join operation. This the join operation, it combines two relation to form a new relation, and it is one of essential operations in relational algebra. Okay, so join operation is one of the most difficult operation to implement efficiently in RDBMS, and it's one of the reason why relational system has intrinsic performance problem. But you still need to understand the use of this joint operation. So we have these four types of joint operation. Okay, so let's look at the first one, natural join. So this is how we represent the neutral join operation in relational algebra. So the result that we get, the result of this operation is the set of all combinations of tuples in R and S, okay, that are equal on their common attribute names. So we join the the tuples in R and S that are equal on their common attribute names. So you basically you do the natural join by combining the tuples in R and S, those that are equal on their common attribute names. Okay, the attributes are ABC. So we have AB in R, BC in S. So you do natural join for these two for these two tables. So we will get this result. The common attribute we have A, B, C. Then we have A, B, and C, and then you list out the tuples that are equal. Okay, so you have A, and then you have 1, and you have X here. The next row A, 1, Y. Okay, so it join the tuples in R and S that are equal for both table. So let's look at an example of this natural join or using our dream home database. So here we want to list the client number, the names, and also comments of all clients for who have viewed a property for rent. So here we will look at R is client and S is viewing. Okay, so we will look at these two tables here. So first, we do the projection. So we get the attributes, client number, the names. It's the first name and last name. So from client, we get this client number, the first name and last name, and then you do the natural join of the project with the projection of client number, the property number, and also the comment, okay, from the viewing table. So you will get this result. Okay. So from this natural join, you define or you query the attributes, the attributes from the same attribute from client and viewing, which has the same the same attribute names. Okay, so we look at the rows that is equal and we look at the same attributes name. So you will get this result here. So you get the client number, the first name, the last name, the property number, and the comment. So this all this client has viewed a property, and we also include the comment. Okay, so this is natural join. So this is the first part of our lecture for this chapter. Okay, so for your midterm test, actually we cover it covers up until lecture 5. So lecture 5 is if according to our form B. Dana, let me open it. Just want to discuss with you. Okay, Dana, give me a sec. So that's all for our lecture today. So I because the form B actually stated there we split the lecture in 2 weeks. Okay, so because it's a lot, so I don't want to like burden you also. So we divide the lecture for today into two parts. Madonna, I open the course plan. Okay, so go back course plan. Okay, so according to this course plan, we are in week 5 now, right? So we are at this week 5. So we are here. Okay. So next week we continue on this. So this one is still like chapter 4 relational model. So our midterm test should be conducted in week 7. Okay, but if you see here, the lecture for week 5, sorry, chapter 5 only finish at week 8. But I think because of the midterm test, we will finish the chapter 5 lecture in week 7. Yeah, the week 7. Are you all okay if we conduct the midterm out of I mean night time? Is it okay with you?
Okay.
Um, yeah, maybe around 7. Maybe we start at 7. Okay, but I'm still waiting from the CC. Okay, so I will confirm with you again. So if there's changes, like maybe we can conduct it during practical, maybe because the lecture we will cover the chapter 5. So maybe we can arrange to do the midterm test during practical time. But I'm not sure. I'm still not sure if we do this face to face or online. How about the rest of your subject? Your midterm test is conducted. How is it conducted? Online or no update yet? Oh, I see. Um, I remember networking is online. And networking with Dr. Chris, right? Ian, is it? Mm, yeah, actually, like all my other subject also online, but this one I have not get feedback from the CC. Most probably it will be online also, so I will let you know. Yeah, so just to let you know, you can already, yeah, it's open book lah kan kalau online. Okay, so if it's online, if you like me, what we conduct it maybe during lecture or during practical, I will let you know. Most probably during practical or nighttime. Okay, so now is there the other subject already scheduled with you, Ka? have the other lecturer schedule with you for the midterm test? I mean, like fix a date. Oh, okay. So still open lah kan in survey. So I'll try to fix date and time for this chapter so that for this course so that you can get ready. So you can already do your revision for chapter one, and you can also read on chapter 4 and chapter 5. From chapter 1 until chapter 5, it covers from chapter 1 until chapter 5. Okay, I'm not sure if you can get previous midterm question from library. Can you access that? Can you do you have access to the Tayushi library for midterm test? As far as I know, you can only get the final exam questions, right? I'm not sure if for midterm. Can you all access it? Can you try from the repository? Midterm only final exam. Okay. But midterm should be simpler than final exam lah. And I think the time also like short. Usually for midterm exam, you will need to fulfill 50 marks. 50 marks means maybe two question one, and then you have like question one A, B, C, and question two A, B, C. So question one, 25 marks, question two, 25 marks. I have not seen the format for this course yet, but typically for midterm test, that's how the structure is. Okay, but of course, depending on the CC also. I will update you all from time to time. Okay, so any question for midterm test?
No.
Or online library, and I'm talking about online library. Okay, so I will still have time. So I just want to remind you this week for assignment, you need to submit ERD model. Okay, so group leader, you need to submit the ERD, which is the complete entity relationship data model, the business rules, and also represent all the primary keys, foreign key relationships, and attributes. Okay, so you need to do this. So for your assignment, some of you have come back to me and show me your table. So make sure your table are enough to for you to query for data. So for data later on in the next part of your assignment. Okay, so remember this one is the submission for your assignment task one is this week. Okay, so you submit in Google Docs format. Okay, so for this task one you submit in Google Docs format. So later on when everything already finished, then you combine into one full report. Okay, do you have question for this submission of assignment task one? 20th. The I put the the due date is on Friday on Sunday. Okay, Sunday. So if you have questions like you don't know how, like you are not sure you're doing the right thing, so you can always ask me. Okay, I will help as much as I can. Have you all started doing the ERD? I hope already. Okay, ka? Your assignment. Okay, so only a group leader submit, and I want the after the group leader submit, the members also submit so that I know who have not submitted yet. Okay, so please submit. Group leader submit, and your group members also need to submit without attachment. Only the group leader submit without. Only the group leader submit with attachment. Okay. So I will assume that the the first name will be the first name here is the leader. Okay. So we have Noel, uh, Wong, Lim, Daniel, and Solomon. Okay, so all these names, you are the one that will be attaching your submission, and the rest of the members will submit without attachment. Okay, so that's for week 5 submission. And I also already opened submission assignment for task 2 and task 3. So this one is in week 7, so you can already do this. The group leader to submit the following task in Google Doc format as well. So it's this one is another Google Doc format, or you can use the same. You use different letter. When you finish everything, then you combine into one. So you submit another Google Docs for this, particularly for task 2 and task 3. So task 2 is the DDL, the data definition language, statement to implement tables using the Oracle database system. So you need to include integrity constraint, okay, and also the check constraint and default values. Okay, so we have done this in our previous practical. And then data records. Okay, data records. You need to insert sufficient data records for each table that you have created. So your transaction table would have more records than the best table. Okay, so here an example: if you have 10 customers, each customer must have 2 orders and per year, and with average of 2 items per order. Okay, so this is just an example. So the best table will be the customer table. Okay, you have 10 records, and then you have order tables and order detail table. So you should have one customer with 2 record, two two order per year. So you will have 20 order, 20 records of or in orders table, and then you have the order details with each customer have 2 orders, and each order will have 2 items, and you should have 40 records per year, right? So you should create a sample data that has different date, month, year to simulate a real world environment. Okay, so make sure you include all of this. Okay, so I want to remind you that for this course, you only have this assignment and your midterm test and your final exam for your marks. Okay, so I want you to do your assignment. Please do your assignment like wholeheartedly so that you can get good marks for your assignment, and also of course score for your midterm test. So final exam at the moment it's still face to face. We'll see how it goes with the current situation. Do you prefer face to face or online exam? Like you don't know what to expect anymore, right? Same here. I also don't know what to expect anymore. Like going to the college, I haven't gone to the like online. You can score more, right? I can understand also your situation. Like going to a face to face exam, like totally new thing. You will get definitely different marks from what you get from online. We'll see how it goes. We'll see how it goes. Yeah. So do you have any question for the submission for your assignment?
No.
Okay, so far okay. Ah. And now I want to highlight the practical. Most of you, or some of you, I'll show here who have not submitted yet. Okay, so I really want you to do this practical. You submit so that I know your progress. Okay, I know where you at. So practical one, 7 have turned in. I appreciate your like, even though like some of you like it's not complete, but still you have you show that you have effort to do this. But I'm not saying that the other don't have the effort. Like you see, Noel have something already. Well, Daniel and the rest have not attach anything yet. So I hope those these names that have not do anything, have not submitted this yet. It's I want you to like challenge yourself. Please do submissions so that I know where you at. Okay, I want to help you. So this practical, even though it's not graded for this course, but it will help you if you need to do the make good, if you have to do the make good marks at the end of the semester. I want to help you, so you need to help me. You need to help yourself first before you help me to help you to get a good marks. I don't want. I really want all of you to pass this subject. Okay, I know this subject is first. It's first time offered in Sabah branch. So I really want to like give a good impression, first impression to the management that all the students, you are all good student. I know. Maybe you don't you have time yet to look at the practical. I can understand. If you don't know how to start, please let me know. Okay. So I'll try my best to help you. So if you're not comfortable like asking me personally, you can ask your friends also. Okay. Try to discuss with your friend, or maybe if you're not like still like blur, you can always ask me. I will try to guide you. Okay. If you need to do like you need to like have a good meet session, I'm okay. But of course need to see the time also lah. Okay, because my teaching hour is 18 hours per week, so we'll see where I'm available. For your assignment also the same. If you're stuck with your assignment, you can always schedule with me. If you want to have meeting, like you want to ask the requirement, what you need to do, you can always ask me. Okay, so that's for practical one. And practical two, this one I think I put the due date. Okay, I put due date, so that's why I can see missing. Okay, so only six turned in and assign here all the missing. It's missing here because I set a due date, so that's why I see missing. Okay, so please make a progress. I really want you to try to do the practical. Just give me the output that what you have at your side. I really hope that you already have your SQL class running to try all the practical. Okay, so um, I can understand if you inform me like you have no time to do this, but I think I always give you the extra. I give you time to do like if you finish lecture early, if you finish practical early, you do the practical right. So really hope that you use the time to do the practical and submit. Okay, so thank you for those who have submitted. And then practical three. Okay, practical three, the PLSQL, so only 4 turn in, and then the rest have not turned in yet. Yeah, this one I did not put any due. Okay, so this one I hope everyone have seen this. Also, I've shared how to check uh, errors with the stored procedure. So last during our practical session last time, the previous practical session, I think is Ian can ask how to check. So this Russell has found the way to do it. Can show errors to see the error with the stored procedure that you compile. Okay, thank you, Russell, once again for sharing. So please, those who have not done anything yet for the practical, please do do something, do your submission. Okay, those who have submitted, I have looked through your submission. I will try to get back to you as soon as possible to give you feedback on your submission. Okay, so we still have time now. So maybe those who have not submitted yet, you can go and check the practical that you have not submitted yet. So you can plan when you want to do it. So it's actually you can refer to the recording and you just follow and you give the output, put it, you screenshot and put in the Google Docs, then you just submit. Okay. So you can plan like maybe if you have extra time of 1 hour, you do the practical 1 hour, practical to 1 hour. Yeah. To see where you are available. I know most of you have like 4 to 5 subjects, right? Do you have 6 subjects? Anyone have 6 subjects? Anyone? 5 bahkan kamu punya subject this semester? Oh, 6. Yeah, so it's I know it's tough on you. The other subject also got like assignment, got oh you have FYP now, Ian. Yeah, subject juga tuh you get grade for that. You all are doing FYP right now or proposal stage. So it's a little bit tough on you, right? So I can understand as well lah. If you like, if you I would appreciate if you can inform me why do you have not submit your practical, because I really need you to do it, because I will not know your level of understanding if you don't like submit anything. Okay, and I also cannot help you if like I'm being asked, like I'm being questioned why all these students did not submit. So at least if you inform me, I can cover for you. Okay, because if I don't know anything like why you did not submit, maybe you have problem installing the SQL, right? So you need to tell me. Okay, all right. And most of you know my style already, right? So you can always like reach out to me personally and tell me your problem. Okay, don't keep quiet, please. So I think I can let you go now, but you don't leave the session yet. Please like look at your practical submission, and we will continue our lecture next week. And any update or midterm test, I will let you know. Okay. Do you have any question before I let you do your own thing? Can sure, Noel. You want to ask now or you want to ask personally? You want to type in the WhatsApp pun boleh. Type in.
Uh,
Oh, okay.
no, second.
Okay. Ask lah. What is it?
So, can I present?
Oh, you want to present? Okay, sure.
So, based on the question, assignment question, each order must have uh, two order details, kah? Yeah. So,
Yeah,
yeah, I don't
at
know how
least
to
at.
I don't
Oh,
know how
that
to
one is.
include.
Oh, that one is in when you insert data. When you insert the data, not at this stage.
Oh,
Yeah, that one is when you insert data. Remember in practical one, right? You created the database, you insert data. You create like one person. You will need to have two orders, right? That one is when you insert data into your database. This stage you're doing now, this one is your ERD, right?
yeah.
So your ERD, you just show the tables and the attributes.
But
So the mm-hmm,
in the ARD, there's no like this one. We assume this is the orders, right? Order
mm,
table, but there's no
mm-hmm.
order details table.
Um, that the one that in the assignment instruction, that is only an example.
Oh,
Okay, so meaning to say, I cannot see, but hold on, let me check. Apa? Kaji dulu. So you have member. So you have so one member must have uh, bought a ticket, two tickets,
Oh,
right?
like that. Oh,
Yeah. So itu nanti in the when you insert data. So one member should buy bought two tickets and get get two tickets. That means two schedule lah kan, because two tickets you can put in different date or different time, different date, and two different schedule in your
oh,
case.
okay,
Yeah. Okay.
okay. Thank you, miss.
That's all. Did I answer your question?
Oh yeah. Is this enough? I put the primary key and the foreign
Mm.
key. Is there
Foreign key.
anything?
Where's the foreign key? Foreign key.
Oh,
I don't see foreign key.
foreign
Oh,
key must have the
or
exclusive.
okay. Oh, okay. Okay. Yeah, should be okay.
Oh,
Should be okay. Yeah.
okay.
All right.
No, thank you, miss.
Okay. The rest, do you have any question? So far, okay. How about uh Lim? Your group, okay. Okay. If you don't macam don't keep quiet. If you need guidance, let me know. Okay. Or you can ask your friends also lah if you want. Okay. So I'll let you do your own thing now, but you left the Google Meet session at 10:50. Can you do that? 10:50, then you left the group. Okay. So thank you so much for your attendance today, and thank you for your uh, participation in the lecture and sharing from your side. I appreciate your participation and your attendance. I'll talk to you again on Friday. Yeah. So you go and check which practical you have not submitted yet. Okay. Thank you.